down thing, and any one of these paragraphs could be a very long discussion, so maybe after we go through this, we can get into the details of it. Can you hear me?
A little closer.
A little closer? Easier to move me than the microphone. I'm Gary Braxma. I own a small company called Braxma Engineering. We've been doing electrical designs as Braxma Engineering for 14 years. I've been doing it as an employee for other people for 32 years. And right now I'd say 1/3 of our work is industrial design. We mostly work for Phillips 66 Ferndale Refinery. We've also done a lot of commercial building work, and we've done some of the biggest projects in the state. We were the owner's commissioning agent for Seahawk Stadium, so you're probably wondering what that has to do with RV park design. Most of the people we work for are very discriminating, and we don't just throw an answer at them. We have to find the right answer that suits them. So I think that suits very well for RV parks, and we've had a good history of doing some RV parks over the last few years. We've worked at 7 RV parks just recently, including 4 large membership parks similar to Port Susan where there's ownership. And in some of those cases we've cut their electrical construction bill in half. So that's where I just like to leave the discussion and say, well, that's it. We've done a good job elsewhere, but Don and Brian asked me to explain why we're even talking about it. So we're going to go back and build a little bit of a story leading into why we're here and why we're talking about this. Electrical systems do have a finite life expectancy, and there's some aging mechanisms that go on. And if you have a raise of hand here, how long is an electrical system supposed to last? I'd say that the standard answer would be about 30 to 40 years. The conductors and the insulators can age. Some of it's due to the flow of material away from the connections. Some of the connections will come loose. Some of it's when the insulation gets brittle. Not all of that has happened at Port Susan. We've not really done an in-depth study here as to the aging as what's going on, because that gets costly, and usually the answer is, well, it's old. We knew it was old and it needs replacement. So that part of our study was saved. Connectors and terminations age as they lose tension, and there's a mechanism, if you have any aluminum conductors especially, that as they heat up, through increased current demand, they'll swell. As they release, you get a little air in there, you get corrosion on the joint. Now it heats up a little more the next time. And this can exacerbate eventually aluminum wiring. Connections are usually suspect at some point. The equipment itself, the enclosures are going to rust and come apart, and we've looked at a lot of parks, and usually at 40 years of age there's not much left of the panels. You try to open an outer panel and the inner panel will come with it. So a guy opening up the panel to reset his breaker ends up looking at a bunch of live wires that are exposed, and everyone in this room here is probably okay with that, but someday it's going to be a teenager or a younger child that does that. We've seen a lot of broken conduits, and I'm talking in a general sense at other parks. Our overview at Port Susan is that things were in pretty good shape. The panels were not falling apart to the extent that we've seen elsewhere, but there's still issues. We didn't do a total inventory and say, well, here you've got 400 problems that need to be fixed, but we went to look at this just to see what the general arrangement was, and the one place we looked at had two potentially lethal problems with it. We have an open neutral conductor in one of the panels, right? Just the one by chance we chose to look at, and we also had somebody had plugged a 60 amp breaker in to feed their number 10 copper wire. So clearly there was evidence that somebody was exceeding the loads. So that's kind of the long and short of it. We're talking about something with a 40-year life expectancy, and we're approaching that age, and we didn't put a lot of time into proving that at this site. The issues, just to go to the fundamentals here, is it's the safety of the system. You don't want to have somebody's grandkid get electrocuted because a breaker fell out inside the panel and the outside case of the panel got energized. And that's a situation we've seen in other parks. So it's just the most basic level of safety. Safety of the operations. There's no disconnects here, so if the guys want to work on a panel, they have to either call the utility in to turn down the whole neighborhood, or they have to work on it energized, and that's a compromise. The reliability of the system, I don't think that I've heard a whole lot about unreliable operations here at Port Susan, and I think what Don told me in terms of number of failures per year is pretty low, so I can't say that's a very compelling argument that you've had. You know, we've been at other parks where they'll have 12 failures in a weekend. And, you know, at that point, people just aren't able to use the park, and that's indication that something's wrong. The capacity is limited, and this is a big thing. You've got 30 amps provision for each site, and that's all multiplied back into the distribution system. And as I drive through there, there's very few sites that would be adequately served by 30 amps. 30 amps is one RV with no accessory buildings, not a park model, and it will work, but it becomes a life safety issue if things are being overloaded and overheating. And then there's some other concerns we had in the report. The work we completed, we were talking to Don and then Brian, and all of a sudden I got a phone call from Brian. He says, we need some road crossing locations. So we actually started this backwards and said, well, here's if we were going to replace the distribution system, where you would put the road crossings in. I think there was a paving project going on at that time, and he wanted to get the road cuts in before the paving was completed, which makes good sense. Then we did a report, a preliminary report that kind of got us started, and then we reviewed the existing arrangements. We didn't do an inventory, like just keep emphasizing that. We didn't build a case against what's there. We just looked at what was there to see how we could use it. We did the load information. We compiled to determine the PUD transformer replacement, if that was necessary, because that would be a big capital cost if the transformers that are on site needed to be completely replaced. From what I understand, the PUD has recently replaced the cables over the last few years. I'm not sure exactly if that's the whole park. But the results of our study of that was that the transformers do not need replacement. So we pulled that out of the construction cost if that was an unknown. We compared cost estimates and possible replacement solutions. We did quite a bit of that. That's really where my contribution comes in, is if the decision's made to replace this, how can you do it most economically? And we probably did no less than a dozen different configurations trying to optimize the cost. The options we discussed, maintain the existing system as is. And what we're coming up against is the equipment life expectancy. And we can say, well, there's nothing wrong, or it's looking good. We could go out there and repaint all the panels and do a little bit of rust control. But we've been there and done that in a lot of places. Our experience runs deep in this, and usually at the point where you're hitting 40 years on an electrical system with public exposure. I'm not saying go home and rewire your house because it's 40 years old. But, where you're out in the elements and there's people around and you've got that liability, 40 years life expectancy is asking a lot. The 30 amp outlets, that's a problem. The aged equipment system does not meet modern code. And there's a couple issues there, and they're not necessarily material issues, but the meter bases aren't UL approved. And so if we do any maintenance on there, that could become an issue if an inspector's looking at that. The meter bases are just fine. I don't see that as a risk. They're holding together pretty well. But if you came in there and started doing a partial remodel, and that'll become an issue later into this report, then those meter bases suddenly become a liability, because the inspector's not going to let you just leave something in place that doesn't meet modern code. Service disconnect requirement, same deal. We could retrofit a service disconnect. Well, at that point, you're biting off the major part of the expense, because the meter bases would have to go with that, and now you're at 80% of the cost of replacing the whole thing. The system must meet code. If we did just maintain the system and offer optional 50 amp systems, we'd end up intermingling the systems, which I'm not sure that's 100% legal. I did a little code research on that, and I can't see something that prohibits that, but it's a life safety liability. If you've got two power systems going through a neighborhood and suddenly there's a calamity and you don't know which power system to shut off, to have these two mingled. There'd also be questions of whether you could even install one without cutting the first one into little pieces as you're trenching through the same neighborhoods, the same locations. Sorry, I jumped ahead here to part B there, if you're following. If you do maintain the existing system and offer optional 50 amp service, all the inherent shortcomings of the 30 amp system would still be there, including the age of the equipment. The service disconnect becomes a liability without an easy answer. System still needs to meet code, and I would say at that level of remodel, they would want everything brought into code, and then there's a big cost disadvantage. So we focused most of our time on replacing the entire secondary system, and that's not something we really developed on Port Susan's time chart. We've done this at two other parks, and that's the answer that always comes up. We've worked this through longhand at Black Mountain Ranch up on Mount Baker Highway about, I think it was in 2003. And after we exhausted every possible venue to retrieve the electrical system they had, it was apparent that we had to replace everything. So some of that came out of this work, but we didn't, that wasn't the emphasis of our efforts. The cost estimates to replace the secondary system. Now we took the transformers out of this, that'll all stay as it is, and we verified that the load was not going to exceed what capacity was available. To replace part of the system offering 50 amp service to only some of the lots is estimated at $4,585 per site. So if you offered that just on a kind of a smorgasbord basis, that would be the cost. That's actually a low cost, that's optimized. We've seen places where putting in individual sites is $6,000 per site. So $4,585 would be a very good cost if we offered it just on an optional basis, member option to do that. And that doesn't address the code issues. That was a cost estimate, assuming we could just put those in and nobody would hold us liable to bring the other systems back up to code. So there's some big open questions there that have not been dealt with, but that was kind of put in here as a background as to why we're not pursuing that. We wanted to know what cost we're not doing. To replace the entire secondary system with 50 amp distribution, and that would still allow the 30 amp access. Cost estimates range from $2,236 per site to $2,827 per site. Once again, those are optimized costs. They're a little different than those in the report. We had a copy of the report here because we added excavation costs to this because we wanted an all-in cost. So that would be the cost per member to replace the entire secondary site, secondary distribution with 50 amps to each site. Late after we went through that, then the questions were raised, how much would we save if we only replaced it with 30 amp service? So we did another cost estimate, and of the most economical one, 50 amps, we could drop that by, to 92%. So there's not a great amount of savings just to go down. The pedestals are going to cost you about the same. The wire size will go down a little bit, not a whole lot. And basically the distribution panels would go down in cost a little bit. But there's not a huge savings to go from a 50 amp service down to a 30 amp service if we're going to replace it just in kind. When we went through this, we also looked at one, because there's a lot of complicated considerations, like where do the meters go if we replace the system, because those old meter bases won't cut the mustard. And the most economical way to do this would be to put the meters back on the pedestals on each individual site, because those pedestals only cost a nominal amount more than an unmetered pedestal. And it avoids buying a big piece of equipment for all the meters to be sitting in by the transformers. So that would make meter reading more complicated, so we did a little bit of work into what automated meter reading would cost. And so there's been quite a bit of alternative options fleshed out that we've discussed with Don and Brian as we're going through this, just to make sure we're covering all the options and trying to be realistic. So that's kind of the long and short of it, and I would say the conclusion is a member who spends $55,000 on a park model trailer isn't able to get the benefit of this investment without adequate power. Even without a park model, added capacity is needed if accessory buildings or plug-in appliances exceed a single 30 amp circuit. And we've seen that manifest itself when we've completed these jobs at other parks. When we were wrapping up Black Mountain Ranch, people were all of a sudden discovering they could do things with their RV that had not been available because only half of the circuits were heated up with a 30 amp 120 volt service. And by the way, a 50 amp park model service is 240 volts. You multiply the amount of watts available from that, the code tells you it's 9,600 watts. 30 amp 120 volts, 3,600 watts, so you're almost tripling the power available. That makes a big difference if you have a big RV. It would seem to me that that would also make a big difference even if you have a small RV with an accessory building with a fridge plugged into it or anything of that nature, or if you're living here permanently. I think that to require someone to live on a 30 amp 120 volt circuit, you know, there's going to be places in society where they say that's punitive. So we're, you know, you can tell I'm a fan of electricity. It's my career. I think the evidence is that members do need this power, and that was indicated by breaker replacements discovered. If folks are out there plugging in bigger breakers, and we made a note of this to Brian, and he went and they did a walk through the whole place. They found a dozen breakers where people had. So that's pretty strong evidence that you're seeing the need to the point where people are taking matters into their own hands. At that point, it becomes a life safety issue. Another thing here, Brian showed me just before the meeting, was a worn through conductor where there's been a little flexure on the water pipe rubbing up and chafing against it, and it looks like the neutral was in the process of being caught. And one thing that happens when you cut the neutral wire, everybody figures, well, that's harmless because it's just the neutral that should be close to ground potential. That's actually where you electrocute everyone, because as soon as you cut the neutral ground return path, basically the electricity is going to try to get back into the ground system. Your trailer skin is tied to ground. It's now carrying 120 volts. You walk up to your trailer. So anytime we see an open neutral, we kind of hold our breath and take a step back, because that could have been an electrocution. That's what we found in the one panel, and I can tell you why that panel was there. I believe the meters were, why that open neutral was in that panel. I believe the meters were retrofitted. And originally, and we're kind of reverse engineering this and saying, hey, how did these guys do it? You know, why did we end up with this kind of thing? And there's a lot of good thought put into it. I'm not criticizing what was done in the past. But it looks like the meters were retrofitted, and so they had to intercept every circuit coming out of the panels, and they had to make a connection, and there was wire nuts. That's actually illegal. You can't use a panel as a wireway. You're not supposed to be using it as a J-box. There's thousands of panels in existence that have wire nuts in them, but you're in an outdoor environment where you have a lot of thermal cycles, so a wire nut will expand and contract and eventually it'll come loose. We saw one laying loose at the bottom of the thing, and you know, thankfully nobody got electrocuted. There's some things that are working to your advantage. You do have copper wiring on most of the little branch circuits going to the individual sites, so that has really served the park well. If we did a replacement here, we've included the cost of copper wiring in some of them, but those tend to be the high-end options. And the way we would avoid the problems with aluminum wiring would be to put it in conduit. And that aluminum wiring in conduit would be less expensive at this point in time than copper wiring direct grade. We've seen where putting a conduit system in did not add a whole lot to the cost because the contractors could skip the select fill that we would require if it was direct grade. You know, if you want to bury a wire in the ground, the way to do it is to bed that in something without rocks and sharp things that are going to nick the wire. And because we were putting it in conduit at other parks, and just they could make hay and just not pay a whole lot of attention to back, use the original spoils. This may be considered an investment in the park, adding to the value of the sites. I'm just throwing a few arguments out here. One park we've looked at east of the mountains, they had sites without power listed at $4,000 per site to purchase a membership, and sites with power listed at $14,000 per site. So gives you a little idea. I mean, that's just common information, how much proper electricity is valued. And we're talking about, and I think this is the biggest issue, is we don't really know where we're at in the life cycle here. I have not heard from Don or Brian that there's that you're hitting the escalating failure point, and that if we don't do something by next year that it's going to be in a total meltdown. I'm not going to say that. That's not true, and there's no evidence here indicating that. There's been some areas that have been hot spots and some areas where people want 50 amp services, but we're looking at this 40-year life expectancy. To put a little contrarian thinking on it, I understand the lease with the park is coming up due in 40 years. We have 20, something like that. Between now and the end of the park's life expectancy, I think it would be very imprudent to think the electrical system is going to survive. You're getting to the point where you've got 40 years left. If we put it in right, that would get you through the 40-year life expectancy. You get maximum utilization of what you put in now during the next 40 years. I'm kind of playing it backwards on you there. That would allow you to maximize your utilization of what you've paid for over the next 40 years. The next steps would be to determine a path forward, a schedule, determine financing, determine optimized configuration to minimize cost while providing complete service. And some of those all dovetail into each other. We've had to change paths. We're working right now at Lake Tyee RV Resort by concrete, and we're doing a completely different configuration than what we thought we would because we've met with the inspector there. We're spending $200 extra per site to save the individual owners about $1,500 per site of site rewiring. So that's the way we approach it. We kind of try to find the right solution, and some of that comes out as we get into the deeper design. So that's the long and short of it, and we'll open it up for questions.
Yeah, I'd like to frame that first a little bit more for the audience. First of all, Gary doesn't represent any construction companies, in case you're wondering. It's totally separate. You probably work with a lot of different construction companies that do this type of work. Secondly, there's been no decisions by the board reached any way, shape, or form on any direction to go on this. As a matter of fact, I asked the board to put together a subcommittee to work with myself, Brian, and Gary moving forward, so we can figure this out a little bit more and take a look at it and see what it really looks like. Additionally, if anybody here, and I know there is, has a background like Tom Keenan and I have, which is a utility base, everybody knows that when you go out to dig something, you call all the other companies that put stuff in the ground. So one of the things I'd like you to consider here is if we do move forward at any point in time to replace the electricity, we might want to spend a little bit more money, but that's up to the membership with regard to laying in cable, for instance, for television and for internet services. That'd be a very simple thing to do while we're trenching, and of course there'd be some more digging involved because we'd have to get back to a couple of central hubs where that service could be brought in. I have already talked to Toledo Cable, and I've also talked to Dish. Both parties are interested at this point in time in further discussions on that. So it wouldn't just be a move if the membership wanted to just to replace 30 amps with 30 amps or 30 amps with 50 amps. If the membership wanted to, they could up the ante a little bit and also get cable services into the park along with some internet connectivity as well to each of the sites. Or that could be an optional thing for however you want to do it. So there's a lot of different ways to approach this thing. The other thing is, in terms of failures that we've had in the park, I mean, we get off and on failures, but the latest things, I didn't hear Gary hit on it real hard, but the heavier used locations are the ones that we've had the most problems with. As you all know, Club 50, the power there had to be replaced. That cable is a heavy use location, and so heavy use cable goes first. That went belly up, and what did we spend there? 10,000, 15,000 replacing that?
10,000.
10,000. We already did the adult club, I understand, a few years back. We did the laundromat when we remodeled it. The family center is already having problems, and of course the chapel has to be replaced. So all the heavy use locations are starting to show.
PUD wire lost, the repair they did last week was because of failure.
Is that right? The PUD, one of the primaries?
Yeah.
So we're hitting that window. We're at what, 36 years approximately? You know, so we're in the middle of that. You know, Gary said 30 to 40. I've heard some electrical guys talk about 35 to 45. We're in that envelope. And then of course the other issue is 2052. So, but that's also an issue that's up in the air because we're going to start having discussions regarding that year. There's a lot of stuff in the mix on all this. So with that, if you've got questions for Gary on some specifics, I'll sit down and be quiet.
John,
Yeah.
before you sit down and introduce the other members, introduce Tom Keene, introduce the other member of the subcommittee from the board and a little bit about his background.
Okay, who did we, was it Tom and Terry? Okay, Terry works for Seattle's City Light. Okay, and Tom comes from similar background to me in the telephone industry, so these two guys are going to be on a subcommittee working with myself, Brian, and Mr. Braxma, and anybody else that the board decides to put on that committee to look at this thing a little bit closer and turn it over. We're not saying that we have to get moving in the next month or 6 months on something like this, but we need to look at it a lot closer, figure out what we want to do, how we want to do it, what the costs are associated with it, over what period of time would we do this. One of the things Gary didn't touch on, and I think you guys all know this, if you take a project and extend it out over a very long time, you're not going to get those economies of scale. You know, so I think one of the numbers you had down here was $7 million for the whole park. You take that project though and spread it out over 10 years, it's not going to look like $7 million, I can guarantee it. So those are things we have to look at as well. How much do we want to do at a time? How much are we going to impact the members by doing the work if we do the work? Lake Connor had part of their project they're working on. I'm not sure how many millions they've already spent, but I think they're only replacing 30 amps with 30 amps is my recollection. But they actually had moved a bunch of people out of a bunch of sites, ordered their wire, and they were going to work on it, and along came that big hurricane back in New Jersey. All their wire went to New Jersey. So their members were without power for a very substantial chunk of time before they could get wire to come in to do the project. So there's a lot of issues with all that. But anyway, that's it. If you have general type questions regarding a bigger picture, I'd be glad to take those, or the board will.
How about the water system that hasn't been mentioned?
Yeah, the water system, the PVC pipe, correct me if I'm wrong, I was doing some reading on that. It's got a life expectancy of up to 100 years from what I've seen. You know, we have our ongoing issues with the water pipe where it's, when it was initially put into the ground, I don't want to get off on water too much here, it wasn't put in sand, laid in like on sand bed and all that good kind of stuff. So we get rubbing with those pipes and they do go out. I think we found one monster leak this year that helped us quite a bit.
Yes.
But I think that's going to be an ongoing situation. There is nothing that says that our water system needs to be replaced, between now and 2052. With the exception of, we know we have one water reservoir that has to be replaced within the next 10 years. And I think I already talked to you all about that being about, $100,000 approximately. So that's a scoop on that. So, like I said, if you have general questions, the board or I can take them on, but if you have electrical questions, Gary's here to answer those questions in detail, okay?
Go ahead.
On the mic out.
Bob?
It sounds like for the future and for safety, 50 amps is a good idea. But as a footnote or a suggestion, just because you have 50 amps doesn't mean your trailer can handle 50 amps. So you could either do a concentrated education to let people know that they probably ought to replace the 30 amp breaker in their trailer. Because when I was a ranger, 90% of the breaker trips were at the pole or at the street, not in the unit. Or another way to do it might be when you set up the new post to go in and look at the unit and either put a 30 amp or 50 amp, depending upon what the unit is capable of. But if you don't do something, people are going to try to put 50 amps on their older units and their breaker hasn't been switched on and off for years, you could have big problems.
the pedestals we're looking at would have